Right, so let's try this redox titration question. Again, it's really important to understand that we have a substance which is impure. So the impurities are not expected to react with manganate. It's only the ion that we are expecting to react. So the first challenge is to write the balanced equation for this reaction, which is here. How do you write it? Well, in this worksheet, they actually gave you this data, these half equations. So then you only have to multiply this one by 5, and then you add it to this one. If they didn't give it to you, which they may not, what you need to know is that the manganate is going to become manganese 2 plus. So then you balance the oxygens by adding water, so 4. You balance the hydrogens by adding protons, so 8. And then the overall charge on the left-hand side is +7. On the right-hand side is +2, so that's why you need 5 electrons here. Okay, so once you've got the balanced equation, you calculate the moles of manganate used in the titration, which is this number. And then, because of the molar ratio, which is 1 to 5, you multiply by 5. And that gives you the moles of iron, 2 plus, from the portion that was titrated, which is 25 centimeter cube. This portion comes from a bigger solution of 250, which is where the 2.55 grams were dissolved. So how much iron do we have in 250? Well, we multiply by 10, and we get this. So these are the moles in 250, which come from this mass of compound. So if you multiply the moles by the EMA, that gives you the mass of iron in the compound. But the initial mass with the impurities wasn't 1.596, it was 2.55. So then to calculate the percentage purity, you do the mass of pure iron, which is what reacted, over the initial overall mass, which contains impurities, times by 100, and that gives you the percentage impurity, or the percentage purity. If you have any questions, please do ask, and that's it. I'm going to try to finish the video, but the computer is really slow, so you can start the video now.